by Phil Barker, Chief Engineer, Hybrid and Electronic Systems from Ricardo. Phil has been in the automotive industry for over 27 years, originally in the field of chassis and vehicle engineering. He moved in 2004 to working with hybrid and electric vehicle technologies at Lotus Engineering, where he held the position of a chief engineer. In 2016, Phil moved to Ricardo to continue work in vehicle electrification. His expertise is in vehicle integration and feasibility of hybrid and electric technologies into existing and new platforms. And for the last 9 years, he has been using this expertise in business development across market sectors, from motorcycles and passenger cars to, more recently, commercial vehicles and the off-highway equipment, which is the part of his presentation. Please join us here, Phil. The floor is yours.
Okay, good afternoon, everybody. This presentation is regarding electrification in the commercial vehicle and off-highway segments. Firstly, I'm going to take you through an overview of the market sectors. Now, the presentation includes quite a lot of detail, so forgive me if I gloss over some of the slides, but I thought the information would be there as useful reference and reading material when you download the pack itself. So, vehicle classifications for on-highway. This is the classification of on-highway vehicles in the USA. So we've got heavy-duty truck and medium-duty truck, both of them with a number of subcategories there. And similar with the bus sector, there are a number of subcategories for the bus sector, going from school bus to city bus to tour buses or coaches as we know them here in Europe. Looking at the US off-highway market, it's segmented into 3 groups based on application, size and function. So firstly is agricultural and forestry. So this is tractors of varying sizes, combine harvesters and other harvesting equipment, and forestry equipment. And then we have construction, where we've got a number of subcategories there as well for the construction industry. And similar for mining, where we look at haul trucks with very, very heavy payloads, underground mining, and other equipment for mining. In Europe, the vehicle categories are based on the United Nations ECE regulations, and these really span across the whole of the vehicle market, from motorcycles and three-wheelers to light passenger vehicles, light goods vehicles, and then heavy goods vehicles and buses. So you can see the vehicle categories there for the European market. So looking at the key drivers and benefits now. For the hybridization or electrification of commercial vehicle and off-highway, the key market drivers are listed here. Legislation and emissions is the obvious one. The standards are increasingly stricter in many, many countries. Hybridization allows the use of smaller engines working more efficiently to meet emissions standards. And the pure electric vehicle would allow vehicles to be operated in zero emission zones. An important factor for the commercial and off-highway, probably more important than passenger vehicles, is fuel economy. And we can see that hybridization can have a significant impact on fuel consumption. There's also a risk of high fuel prices, and I'll go through an example of what fuel prices mean in this market sector later on. Many countries are reducing the subsidies for fuel, and fuel economy regulation for off-highway products is now under discussion, whereas it's been in place for the passenger vehicle market for many, many years. Productivity enhancement is a very important factor for commercial and off-highway, very much more important than passenger vehicles, because total cost of ownership is the key for these kind of vehicles. And then improving maturity of technology. These market sectors are now have got a great benefit in the work that's been done over the last 20 or 30 years in the passenger car market, particularly with respect to cost and reducing costs of the various pieces of equipment that are required for electrification. So, looking at a little bit more detail for the benefits of hybridisation. Improved fuel economy is obvious. Engine downsizing, not necessarily so obvious as fuel economy. But what it does allow in things like off-highway machinery, it may allow you to go down a classification in emissions limits. So that's an important consideration with engine downsizing. Improved productivity. The electronic control of these systems leads to improved productivity. Lower noise, certainly for electric-only operation, there is a much lower noise on these vehicles compared with a combustion engine running. Reduced losses. We can electrify ancillaries, which means that an engine itself has got reduced losses. And then increased functionality. And this potentially leads to autonomous operation, and there's a little bit of that later on in the presentation. So, the key market drivers and what are the implications of these market drivers. So we take the legislation, exhaust emissions, the key factors here are NOx, particulate matter and CO2 regulation, which has been discussed about coming in the future. Fuel consumption and extension of scope. The emissions regulations now are looking at widening the scope, widening the kind of vehicles and machinery that are going to be applied with these regulations. So the implication of that is a significant increase in the demand for lower and zero emission solutions. Next one's noise emission. And this is a particular benefit for an operator if he's working long hours and the noise of the vehicle is less than a combustion engine, then it has a benefit for the operator. So that's increasing a demand for low noise solutions. Financial incentives, there's public subsidies and incentives with respect to these vehicles, so that is driving the demand as well. Fuel price to an operator equals cost. So if you reduce the fuel consumption, you're reducing the operating cost. And then trust in the technology. The technology is well understood in the passenger car market, so that's leading to increased trust in the emerging markets using these kind of technologies. Looking at the technologies themselves, storage technology is probably the biggest factor with respect to this. Power density, energy density and cost per kilowatt hour. Motor and inverter technology. What's the power density of the technology compared with a combustion engine? What's the cost compared with the combustion engine? Fuel cell technology. The presentation that follows this presentation is about fuel cells, so I'm not going to dwell on that. But the key factors there are tank size and weight, hydrogen production and fueling infrastructure. The tank size and weight is a significant one because hydrogen is interesting stuff. Whatever you put it in, it wants to get out. So the construction of the tank is quite interesting in itself. Automation technology, so controllability, autonomous driving, process innovation. So all these drivers are looking at an increase in the penetration of electric vehicle technology in the market sector. Many cities now are looking to actually discourage cars and encourage new technology. The fairly striking fact here is that the quote there in the middle, air pollution in Europe is causing nearly 500,000 premature deaths every year. So what can we do about air quality in the big cities? Number of examples there. London have introduced the congestion charge many years ago, but some of the things they're talking about now is the City of London banning diesels by 2020 and going clean by 2030. Paris already has a car ban, selected areas to be zero emissions by 2020. A number of German cities are planning to ban cars, same as Oslo. Madrid are going about it in a slightly different way, in that they're mandating every fuel station to have a fast charger installed. And they're looking to ban cars from the centre by 2020. Copenhagen to be carbon neutral by 2025. And there are many cities that are having a huge focus on pedestrianisation of the city to make it impossible or impractical to actually use a car. So with respect to cities, there's a global initiative set up called the C40, and this is created and led by cities and has got a focus on tackling climate change. So this will lead to an improvement in air quality in the cities. So looking at the legislation now, for heavy duty commercial and bus, this is the exhaust legislation that has been put in place in various regions in the world. And what can be seen as entirely obvious is globally exhaust emissions are not harmonised at all. And then in the non-road engines and vehicles, the off-highway equipment, again globally the exhaust emissions regulations are not harmonised. So we've got to work with the emissions regs that we are selling the vehicles and the machinery in. Commercial vehicles, fuel efficiency is the dominant driver for electrification. So if we look at the customer aspects of these kind of vehicles, firstly, heavy duty truck. Fuel efficiency, very, very important. Recuperation, regen braking, not necessarily important, because these kind of vehicles have long operating hours but are mainly steady state, so they'll get onto the highway and it'll be steady state for hours and hours. So recuperation really doesn't come into it. For medium duty truck, controllability and productivity are very important. The cost advantages with having a hybrid in the city with lots of stop-start cycles are there. There's an additional benefit. I mentioned noise earlier. If we look at vehicles that are operating early in the morning, for example, refuse vehicles, if they're electrified, then they're creating less noise. So it's less of an intrusion in the early hours of the morning. And if we look at bus, fuel efficiency is the very important aspect of this, particularly if the bus is operating in an urban environment where there's lots of stop-start. That means you can have a lot of recuperation. So that's an important consideration in an urban environment for an urban bus. And the other aspect of it is the noise pollution. That's reduced in an urban environment with electrification of a bus. Looking at some of the other off-highway requirements now, construction and forestry, fuel efficiency is very important. If we look at agriculture, there's an increasing number of work functions, so the controllability of an agricultural machine is very important. And productivity for an agricultural machine is worth a lot to the user, to the operator. And then mining. If we consider these vehicles are being used underground, then the air quality has got to be very, very good. And mining operations put a lot of capex into equipment that cleans the air underground. If the vehicles are electrified, then that wouldn't need to happen. If we look at fuel prices, this is looking at a worked example of the difference that the fuel price makes in return on investment. So if we look at the prices of fuel in the US, in the UK and China, and if we look at the worked example of looking at an excavator, 170 kilowatt classification excavator, 1,400 hours annually, 45 litres per hour consumed with the diesel fuel. So we work out the annual fuel cost in the three regions, the US, UK and China. And if we consider that mild hybridisation would have a benefit of 25% improvement in fuel economy, we can then work out what it means in fuel savings over a year's period. And so you can see that the UK, the fuel saving over a year is roughly 3 times the fuel saving in the US. So that probably is an indication that the uptake of these kind of technologies in the US is not as fast as in the UK and Europe. System cost is a major barrier. If we look at component and system cost, particularly the energy storage, big vehicles need big batteries equals big cost, but the cost has dramatically come down recently. Second major obstacle is power density. An e-machine is 2 to 3 times larger than hydraulic motors, which are very common on off-highway equipment. Service and maintenance requires huge investment. If we're looking at electrification, we're generally looking at high voltage, and the training of personnel to work on high voltage needs to be intensive and certified due to the safety aspects of high voltage. In the UK, every single Toyota dealer has at least 2 technicians that are trained and certified to work on high voltage systems. So there's the aspect of service and maintenance when we look at electrification that needs to be considered. Safety concerns with high voltage. Return on investment, we've got a little bit more detail coming up with return on investment for the different sectors. Fuel prices have a large influence, as we've seen with the work example, and the unfamiliarity with these new technologies in these emerging market sectors, and the reliability of the electric components. The combustion engine has had well over 100 years of development. The electrification technology has not. A little bit of detail on battery pack roadmap for cost. You can see the graph at the bottom left there, looking at the cost and how the cost has altered over time. And a few snapshots really. In 2010, the cost estimates for a battery pack were above $1,000 per kilowatt hour. In 2016, it had tumbled down to just over $200 per kilowatt hour. We know that Tesla reported to be paying $190 per kilowatt hour for their battery packs. GM have got a contract with LG for the cells at $145 per kilowatt hour. So you can see that we're already beating our targets in cost for battery technology. And so this means that heavy-duty vehicles can now have the benefit of the developments that have been going on over the last 20, 30 years in batteries in the passenger car world. It means that a battery on these big vehicles, it may not mean that the vehicle is cost parity with a combustion engine vehicle at the point of sale. We can see that coming in the passenger car market, but not in the commercial vehicle market. However, for the total cost of ownership over its lifetime, an electric vehicle will start to have some payback. High capex costs need amortization over time. And if we look at the various different sectors in the market, we've got the rental market for construction and agricultural equipment. The payback time is between 6 and 12 months. If we look at material handling equipment, it's between 12 and 18 months. Agricultural equipment, 24 to 30 months. Commercial vehicles, 36 to 60 months amortization requirement. But if we look at the equipment, the hybrid equipment, the average amortization of the hybrid equipment is longer than all of those. So is the market going to be willing to accept that? If it's not, then what can we do to make a difference to that? Fuel consumption costs have got the largest impact in determining the payback period. We've already seen the worked example in the UK. Now we're comparing the US to Europe. If we look at mild hybrids for construction excavators and refuse trucks, The technology payback in years is roughly twice that in the US because of the price of fuel. It's roughly twice that in Class 8 refuse trucks because of the price of fuel. Slightly less than twice in the construction bulldozers, nearly twice in a box truck. So the total cost of ownership is very much dependent on the fuel cost. Now we look at some of the technologies themselves. If we look at the architecture options, we got primary energy source of combustion engines, of fuel cells and batteries. We've got vehicle propulsion to consider. So that could be hydraulic and mechanical, hydraulic and electrical, electric only, and then mechanical and electrical combination, and mechanical alone. If we look at the work, so if we take an excavator for example, this is the excavator arm and the bucket. That could be operated hydraulically or a combination of hydraulic and electric, electric only, mechanical and electric, or mechanical only. And the storage systems themselves, hydraulic storage by way of an accumulator, electric storage by a battery or a supercat, or it could be a combination, mechanical storage, flywheel, or no storage at all. So the industry has come up with a number of, shall we say, standard architectures for hybridization and electrification. The first one there is known as a P1. This is where the electric machine is mounted on the crankshaft. The P2 is where the electric machine has got a clutch between it and the crankshaft. And so the benefit of this is that you can isolate the combustion engine and switch it off and operate electric only. A P3 system, the electric machine is on the output side of the transmission. And a P4 is where we've electrified the rear axle. We can also look at combinations. We can look at the top right, a P1 and 2, where there's two electric machines. We can look at a stop-start system, where we've got an electric machine that's driving the accessory drive belt. And the more powerful machines now can actually torque assist to a small amount. And then we've got series hybrid. This is where there's no mechanical link at all between the combustion engine and the vehicle itself to propel the vehicle. So the combustion engine purely drives a generator, and that electricity is used to drive the vehicle and the implements. And then we've got a hydraulic hybrid, where the engine drives a pump, which then supplies a hydraulic motor to drive the wheels. And in there is a high pressure accumulator as an energy storage system. So now we can consider those different architectures, and we can consider combinations of those architectures. So this slide is just showing the degree of electrification from the left-hand side, full electric, to the right-hand side, no electrification at all. And along the bottom, we've got the suitability of the technology for the different vehicle classifications. So buses, medium duty, heavy duty, and then the off-highway classifications. So firstly, for the battery electric, we can see that it's very, very suitable for a pure EV to be applied in a bus application. For a full hybrid electric, it's quite suitable across the board. The reason for that is that we can specify the system depending on the usage. So one full hybrid system may have a very different specification to another full hybrid system, depending on what it's being used for. Then we've got diesel electric, mild hybrid electric, and mild hybrid hydraulic. And again, because we can play about with the system configurations, the system specifications, we can tailor a particular system to a particular usage. So mild hybrid is currently dominant, ranging from micro to mild. And then we've got full hybrid, and then plug-in hybrid. And the difference there is in the energy storage. There's a different battery chemistry for the plug-in hybrid that allows it to be charged from an offline charger. If we look at more system definitions, we've got diesel electric. This is particularly suitable for the very heavy duty applications, such as the whole truck there. We've got battery electric vehicles, very suitable for urban delivery, suitable for buses, and very suitable for underground mining with the air quality that I mentioned earlier. And then fuel cell vehicles. There are certainly prototypes that are running around with fuel cells. In the passenger car world, there are fuel cell vehicles in production, but very, very low production volumes compared with conventional passenger cars. So now a few slides on market penetration. If we look at the US and Europe, this is a number of interesting points regarding the differences between them. So in the next 5 to 10 years in Europe, advanced diesel and natural gas powertrains will predominate, particularly for the heavy-duty vehicles. In the US, there are some companies that are starting to promote the use of electrification on heavy-duty trucks. Nikola Motors with a fuel cell truck and Tesla Motors with the pure electric vehicle truck. California, for many years, have done their own thing, and it seems like they're continuing to do so. And a number of states, there's recently an announcement that another state has joined California in how they wish to go ahead with their emissions and fuel consumption regulations. If we look at medium-duty, heavy-duty trucks and buses, and what's been happening in the last 5 years or so, and a projection to 2025, what we're seeing is there's around about a 4% growth with the production volumes of these vehicles. If we look at the market penetration rates for on-highway bus and trucks, we look at a market penetration of around about 17% by 2025, and production volumes raising up to 20,000 vehicles a year in 2025. If we now look at the off-highway sector, it's all about reducing the cost of fuel consumption in these vehicles. So what is the technology that we can apply to off-highway equipment to reduce the fuel consumption and to meet the new regulations targets, the Stage 5 targets? So the off-highway production is showing a slightly less growth rate compared with the commercial vehicle on-highway. So it's less than 2% that we're looking at between 2015 and 2025, less than 2% annual growth rate. And subsequently, the market penetration rates for off-highway are very much less compared with the on-highway vehicles. So looking at the relative values of hybrid systems now, if we look at the marketplace in 2025, we're predicting the electrification of the commercial vehicle market to exceed €340 million for on-highway bus and truck. So significant growth, particularly in buses, with respect to electrification. And if we look at a similar time frame in the off-highway electrification, it's very much less compared with the on-highway. It's only €65 million predicted market value in 2025. So, to summarise, if we look at the commercial vehicle sector and the path to electrification, we got the main drivers there of CO2 and greenhouse gas reduction. We've got pollution reduction, air quality in urban areas. With the air quality, more and more urban areas are looking at creating zero emission zones, and also to reduce the noise in those areas. And so for trucks, there's already examples of electric trucks on the market. There's Cummins with the range extender electric truck. There's battery electric vehicles and fuel cell electric vehicles that are certainly in the pipeline. And then if we look at buses, we've had hybrid buses in London for many, many years now. But buses seem to be making a leap really in hybridisation and going straight to all electric. And the market forecasts are an indication of that. And then there's an example of a fuel cell application on a bus. If we look at the agricultural sector, the main drivers are zero emissions operation, fuel saving and CO2 reduction, total cost of ownership and productivity, and it's cleaner for crops and livestock. And there's examples there of vehicles that are already being produced and developed with respect to electrification. In the construction area, the main drivers are zero emissions, fuel saving and CO2, and productivity. And I just thought I'd put in a final slide about autonomy. The main benefits here are product cost saving, because there's no cab or any kind of human-machine interface. If you're getting rid of the driver, there's a manpower saving there. You're removing humans from hazardous environments. I've had a number of discussions with construction equipment manufacturers who are saying that people are now looking towards getting humans out of the building site and having a building site that is completely free of humans, completely free of any kind of safety implications with equipment and humans in the same space, and increased productivity. And that is it. That is Ricardo's take on electrification in the commercial vehicle and off-highway world.